Okay, dear students, so let us start this new chapter. As you can see, the name of the chapter is light. Now students, this is going to be a very interesting chapter because it has a lot of practical applications, so you'll actually enjoy a lot. Now talking about light, students, so light is everywhere around us, right? Without light we cannot live, right? So you can understand what is the importance of this chapter, right? So can you name some of the sources of light, some of the objects or some of the things which give us light? Very simple, students. The first example which comes to my mind is sun, right? Then stars. What about, students? Bulbs, right? Tube lights. So these are some of the things which give us light, students. Now students, look at these photographs. These photographs show some of the very interesting phenomena of light. For example, let us focus on this photograph. You can see a cat which is actually seeing its own image in a mirror. Right? This is a mirror, and this cat is seeing its own image here, and the image looks exactly like the cat, We all do this every day, right? We all go in front of mirrors in the morning and see ourselves, how we are looking. So in this chapter we are going to study how we see this image, which is exactly like us. Now look at this rainbow. Rainbow is such a beautiful thing that we see sometimes in the sky. So we'll see in this chapter why we see rainbow. Now these are stars, students. At night you can see twinkling of stars. Now this is scene of sunrise or sunset. At sunrise and sunset you can see that sky looks reddish. So these are so many interesting phenomena which are actually based on light, and there are many more such phenomena. So in this chapter finally we'll end up discussing all these things, and you will understand the physics behind these and the science behind these phenomena. Okay, students. So students, there are two parts of this chapter. One is called reflection of light. And another is called refraction of light. Please note the small difference between these two words, students. This is reflection, reflection, and this is refraction of light. Okay. So these are two important sections of this chapter. So first of all, we'll focus on reflection of light. Okay. And once we finish that, we'll move to refraction. So let us start with reflection, students. So dear students, let us look at this room, right? So there are a lot of objects in this room, and this is you. You are standing in full style, wearing a hat and everything, right? And you are looking at different objects. Okay. Now students, my question with you is, how are you able to see these objects? How are you able to see all these objects? Tell me. I think, students, your obvious answer will be that you are able to see these objects with the help of your eyes, right? With the help of your eyes. That's definitely true. There's no doubt about it that you are able to see these objects with your eyes. But there's a catch to it, students. What is the catch? If I switch off the light in this room, will you be able to see all these objects? No, definitely no. So obviously, along with your eye, light in this room is also very important for seeing all these objects. So we can write this down, students. What light is needed? Light is needed for seeing objects. Light is needed for seeing objects. If you want to see objects, you need light. If there will be no light in this room, there's no way you will be able to see these objects. Right? Now students, see, I'll tell you more details how you see objects. See, this is a bulb. This is a source of light, right? So light is coming out of this bulb. Right? So we can think that light rays are coming like this. Right? Light rays are coming like this from this bulb in all the different directions. Light is spreading from this bulb in all different directions, right? There's no doubt about this, right? Now some of these light rays will come into your eyes, isn't it? Some of these light rays will come into your eyes. When these light rays come into your eyes, then you are able to see these bulbs, students. Then only you are able to see this bulb. Similarly, we can talk about this bulb also, students. From this bulb also, light is coming out in all different directions. Okay. So when some of these light rays will enter into your eye, when some of these light rays will travel and enter into your eye, then only you will be able to see this bulb, students. So this is how we see an object. If you are able to see this bulb, what it means is that some of the light rays which are coming from this bulb are entering your eyes. Okay, students. Now, what about this this sofa? What about this sofa, students? You can see this, right? You can see this. But is this sofa emitting light rays? Is this sofa emitting light rays like this bulb? Like this bulb? Definitely not, students. This bulb is a source of light. It can emit light rays, right? But this sofa is not emitting light rays. Then how are you able to see the sofa? So it's very simple. What is happening here? Look at this light ray which is coming out from this bulb. Now this light ray will come down and strike this sofa. Suppose it strikes here. Now after striking the sofa, this light ray will bounce back and it can go to your eye. It can go to your eye. Some another light ray coming from the bulb may hit sofa at this place and it will bounce from here and go to your eye. Okay, students. So this is how you are able to see sofa. Sofa is not emitting light of its own. It is not emitting light of its own. But the light rays which are coming from the bulb are hitting the sofa. Sofa is reflecting that light ray and that is coming to your eye. That's why you are able to see sofa. Okay. Now how are you able to see this table, students? The similar phenomena. The light rays from the bulb are hitting table, and after hitting table they are getting reflected from here and coming to your eyes. And that's why you are able to see this table. Similarly the case with this table. Why are you able to see this table? Because light rays from this bulb or from this bulb are hitting this table, and then after reflection they are actually coming to your eyes. After reflection they are coming to your eyes, and that's why you are able to see this table. Similarly, why are you able to see these stools or sofa? Light rays from this bulb or maybe from this bulb or from any other source of light are hitting this, and then after being reflection they are coming to your eyes, and that's why you are able to see them. You understand? So whenever you are seeing an object, light from that object is reaching you. Light from that object is reaching you. So we see an object when light rays from that object reach our eyes. The coming light rays may be directly emitted by the object, as in the case of this lamp, or may be reflected rays, as in the case of this sofa or table. Now students, in this regard we can actually define two new terms. So the first term goes like luminous source of light. Luminous source of light. And the second term is non-luminous source of light. So basically there are two type of sources of light. One is called luminous source of light, another is called non-luminous source of light. Now see students, what is the difference between these two? Think about this lamp. This lamp emits its own light. Right students? Its own light. This lamp also emits its own light, right? So this lamp will be called a luminous source of light. So this is luminous source of light. Right? So this lamp is luminous source of light because it emits its own light rays. But think about this sofa. So light is coming even from this sofa or from this stool or from this table. So these are also called sources of light. Because light can reach to your eyes even from these sources, even from these objects. So these are also sources of light. But because they do not emit their own light, so they will be called non-luminous source of light. So this table, for example, is non-luminous source of light. Non-luminous source of light. So we can define luminous sources like this, that luminous sources are the sources which emit light of their own, right? For example, bulb or tube lights. Non-luminous sources are the sources which do not, please pay attention on not, which do not have light of their own. They reflect light from other sources, for example table, chair, right students? So please understand that this sofa, this table, these are also being considered source of light, because light is being emitted by them, light is coming from them, because light is coming from them, right? But as the light coming from them is not their own light, the light coming from them is not their own light, but it is actually somebody else's light which is actually being reflected by them. So these objects will be called non-luminous sources of light, right? But a bulb like this is emitting its own light, so this is a luminous source of light. So okay dear students, look at this photograph and I'm going to give you the best possible example of luminous and non-luminous sources of light. Now look at this situation, you can clearly understand this is sun, this is Mother Earth on which we live, and this is moon, students, which we see at night, right students? Now what is happening in this photograph you can see clearly. Sun emits light, and that light is reaching to earth. Right students? We receive this light every day during noon, morning, right? And this is moon, students. Moon also receives light from sun. And it reflects some of the light towards earth, right? At night we can see the moon. Now why can we see the moon? At night? I've just explained you students how we see objects, right? We see objects because light from them is coming to us. The same thing is happening here. At night what happens? This light from moon comes to us. And that's why we can see moon at night, right students? Now what about this sun? What do you think? It is a luminous source of light or it is a non-luminous source of light? See students, sun is emitting its own light in all the directions. So clearly it is a luminous source of light, right? Now what about moon, students? Moon is also a source of light. For us. How it is a source of light? At night it gives us light. But the light which moon is giving us, or which the moon is emitting, or the light which is coming from the moon, does not belong to moon itself. What moon is actually doing is that it is taking light from sun and it is just reflecting some of that light to us. So clearly students, you can understand that moon is a non-luminous source of light. Right students? So these are the best examples of luminous and non-luminous source of light. So students, enough about luminous and non-luminous sources of light. We have understand clearly what they are. Now it's time to move ahead in this chapter. So I'm going to tell you some basic properties of light, some very simple, straightforward basic properties of light. So the first thing is, light is a form of energy. Now what do you understand by this statement, students? Students, you must be knowing there are many forms of energy. Like, can you name some of the forms of energy, students? Sound energy, right? Then chemical energy. Then heat energy. Electrical energy. Right students? You must have studied about these different forms of energy in previous chapters. Right? So similarly, light is also a form of energy. Now second point. Light travels in straight line. This is a very simple point, students. That when light travels, it travels in straight line, right? It does not move like this. It does not move like this in a zigzag manner, right? It does not move like this. It moves in a straight line. So think about a torch, students. When you switch on a torch, light comes out of it and it comes out in a straight line. Like this, right? It travels in a straight line. Now students, third point is very simple. Light form shadows. So we know, students, what are shadows, right? So in this photograph, this is shadow, right? This is shadow. So light can form shadows. We all know that in childhood we have all played with shadows, right? It's always a fun. So students, now we'll move ahead in this chapter and we'll understand what is mean by reflection of light. Reflection of light is a very important term. We all understand it, but we'll see it in more detail here, students. So students, suppose we have a wall. Now suppose we have a wall. Now a ball is being thrown at the wall. Ball is being thrown at the wall. What will happen, students? From daily experience we know that the ball will bounce back. The ball will bounce back. Right, students? A similar phenomena happens with light rays. Suppose, students, a lot of light rays are hitting this wall. A lot of light rays are hitting this wall like this. Okay. Now what happens? Some of these light rays will bounce back. Some of these light rays will bounce back. However, some of the light rays will not bounce back. So these light rays which hit the wall and do not bounce, no bouncing, right? These light rays which hit the wall and do not bounce are said to be absorbed, absorbed by wall. We'll say that these light rays which have hit the wall have not bounced back. They hit the wall and have been absorbed by the wall. But some of the light rays hit the wall and they have bounced back. So this phenomena of bouncing back of light rays, this phenomena of bouncing back of some of the light rays is called reflection of light. So we can write down the phenomena of bouncing back of light rays on hitting a surface is called reflection of light. Right, students? So you would have definitely understood what is meant by reflection of light. And the another thing which you would have understood is that when light rays hit a surface, some of them are absorbed and some of them are reflected. So when light rays hit a surface, some of them are absorbed and some are reflected. Now students, look at these surfaces. Now this is a very smooth surface, right? This is a very shiny and smooth surface. If you look at this one, this is not that smooth, not that shiny. This is slightly rough. This is somewhat rough, as you can see. And this is very rough. Right, students? So this is very smooth, slightly smooth, rough, very rough. So you understand the sequence of these surfaces. Now see what happens, students. Now when light rays will hit this surface, most of them will be reflected. Right, students? Most of them will be reflected. Very less absorption will happen. Most of them will be reflected. Now, if light rays hit this surface, then lesser amount of light will be reflected. If light rays hit this surface, students, a further smaller amount of light rays will be reflected. Rest will be absorbed. If light rays hit this surface, then most of the light rays will be absorbed and very little will be reflected. So are you understanding the point which I am trying to convey? If the surface is smooth and shiny, if the surface is very smooth and shiny, then most of the light ray hitting the surface is reflected. If the surface is very rough, then most of the light rays hitting the surface is absorbed. So we can write here down that smooth and shiny surfaces reflect most of light. Rough surfaces absorb most of light. So it's a very simple point, students, you can keep in mind. Very smooth surface will reflect most of the light. As the smoothness decreases, more and more light will be absorbed. Okay, students. Now look at this, students. This is a very shiny and a smooth surface, and it has been made from silver or aluminium. Now students, if a very smooth and shiny surface is made from silver and aluminium, then you should remember that they are a very good reflector. They are a very good reflector of light. They are a very good reflector of light. What it means is that if light rays hit this surface, then most of these light rays will be reflected. Most of these light rays will be reflected. So just remember, students, if very smooth and shiny surfaces are made of silver and aluminium, silver or aluminium, they will be very good reflectors of light. Now students, another very good example of very good reflector of light is the mirror which we use in our day-to-day life. So the mirror which we use in our day-to-day life is a very good reflector of light. Good reflector of light. So if light rays hit this mirror, then most of these light rays will be reflected. Most of these light rays will be reflected. We can in fact assume that all the light rays will be reflected. All these light rays are being reflected. Students, in this chapter we'll talk a lot about mirrors, right? We'll talk a lot about mirrors, and mirrors will be drawn like this. Means if I want to draw a mirror in physics, I will just draw something like this. This represents a mirror. This represents a mirror. So basically I have a straight line and then these small lines, right? This basically represents a mirror. And clearly there are two sides of it. So this represents the front of mirror, and this represents the back side of mirror. So suppose you have to see your image. Suppose you have to see your image for seeing like how you are looking and all. So you will stand here. You will stand here, here. So this is the front of the mirror and this is the back of the mirror. If any light ray hits this front part of the mirror, it will be reflected. If any light hits this front part of the mirror, it will be reflected. But if any light ray hits the back of the mirror, then it will not be reflected. It will be absorbed. Okay, students. So this back part of the mirror is not very important for us, because if light hits here, it will be absorbed. This front part of the mirror is important to us because any light ray hitting this front part has to be reflected. Right, students? So in physics, in science, mirror is drawn like this. This is the front part and this is the back part. So students, now we are going to see some terms related to reflection of light. Now look at this diagram, students. There is a mirror here. A light ray is coming and it is being reflected. Okay. So let us see what terms are going to be used here. So first term is very simple and it is called incident ray. Incident ray. Now what do you mean by incident ray? It's very simple, students. This ray which is actually coming and hitting the mirror. This ray which is actually coming and hitting the mirror will be called incident ray. So basically this ray is our incident ray. This ray is incident ray. So we can define incident ray as incident ray is the ray of light hitting a mirror. Simple. Now let's look at the second term, that is called reflected ray. Reflected ray. Again, students, it's a very simple term. You can clearly understand that this ray which is actually bouncing back will be called reflected ray. Reflected ray. And we can also define reflected ray. Reflected ray is the ray of light reflected by a mirror when a light ray is incident on it. Very simple. Now third point, students, is point of incidence. Point of incidence. Now this is again a very simple point, students. This point is actually point of incidence. This point is point of incidence. So this is the point where incident ray is hitting the mirror. So we can define it as point of incidence is the point on mirror where incident ray hits it. Okay, students, very simple. Now the next term is normal. Now students, this is a very simple term once again. Please look at it carefully. So this is the mirror. This is the point of incidence. If you draw a line here, like this, if you draw a line here at point of incidence such that this line is perpendicular to the mirror, this line should be perpendicular to the mirror, then this line will be called normal. Then this line will be called normal. So we can write normal is a is a line drawn perpendicular to mirror. Is a line drawn perpendicular to mirror at point of incidence. At point of incidence, right? It's very simple. Now next is angle of incidence. Angle of incidence. Now what is angle of incidence, students? Now look at this angle. This angle will represent it by I. This is angle of incidence. This is angle of incidence. So this is generally represented by angle I. This is angle of incidence. So we can say angle of incidence is the angle between incident ray and normal, right? So angle of incidence is basically the angle between the incident ray and normal. So angle of incidence is the angle between incident ray and normal, right, students? Now the final term, one more term, that is angle of reflection. Angle of reflection. Now angle of reflection is generally denoted by symbol R. So clearly you can understand, students, this angle will be angle of reflection. So angle of reflection is the angle between the reflected ray and the normal. So this is the angle between reflected ray and normal, right, students? So these are some very simple points, or these are some very simple terms basically which are used when light is reflected from a mirror.